Right, student, good morning. So today we are going to continue our discussion on chapter 5. We have discussed the first two topics. The first topic is money and the time. So for me, finance is about money in the future. So time is important, right? And I know when I do the finance question, I need to draw the timeline, right? To specify the amount of money and the timing of the money. Next, we discuss the future value. When I see the future value, I know they are the later money on the timeline. Right? So next is our present value. When I see the present value, it is the earlier money on the timeline. All right. Okay, so let's follow our PowerPoint slide. You can see next slide, the present value. So we can go forward in time to the future value, FV. Then can we go backward in time to the present value? The answer is yes. All right. And as a matter of fact, finance uses the process of moving future funds back into the present when we value financial instrument like a bond and the stock. We also use it to evaluate investing in project. So in the following discussion, we have one chapter for bond valuation, another chapter, share valuation. Finally, we have project valuation. And when we talk about value of something, we are talking about the present value, unless we specifically indicate that we want the future value. So in finance, present value is more important, right? When we talk about value, our focus is present value. It makes sense to me. Present means today. So what we concern is the value on today, all right? Or present value. Okay. So on this slide, we show you the difference between present value and future value. So finance uses compounding as a verb for going into the future. Right? So you can see the compounding. In our FV, we move earlier money to the future. And you can see the compounding effect. Discounting as a verb to bring funds or the money into the present. So you can see the later money, FV, to present value. This direction is discounting, right? So when I see compounding and discounting, this is my way to remember the two key concepts. When I see compounding, I know today's money can earn return. Right? This is compounding. Right? On the other hand, discounting, when I see future money will involve risk, therefore a lower value. That is discounting, right? So on this slide, we show you the equation. So future and the present value equation. Here, the conclusion is they are the same. So you can see the first equation is our future value equation. So FV is equal to PV times 1 plus I with power of n. To have PV, you can see we just rewrite the equation to have PV. So PV is FV divided by 1 plus I with power of n. So I is a discount rate. So when I see the discount, I know future money involve risk, a lower value, a discount. Right? So I is the discount rate. And the N is the number of period, which can be year, quarter, monthly, and a day. All right. So again, so let me make a comparison between future value and the present value. So when I do the future value, I know this factor, 1 plus I with power of n. This is compounding factor. And you can see the compounding factor is higher than 1. Right? Again, compounding. Money can earn money. Compounding factor. Then in the present value equation, you can see this term, 1 over 1 plus I with power of n. This factor is smaller than 1. This is a discounting factor. All right. That means $1 in the future, its present value is lower than $1. Right? It's a discounting factor. So on this side, we show you an image. You can understand the difference between FV and the PV further. So consider $100 today. So you can move the money to the future 1 year from now. So your $100 will become 110 if our interest rate is 10%. Right, 110. On the other hand, $110 at year 1, you bring $110 at year 1 to today, you can see its present value is $100. All right. So for me, PV and FV, we use the same equation. The difference is the time. Right? So if you move the money to the future, you have future value. You move the future money to today, we have present value. Okay. Now we are to give you several examples, right, and to do the present value calculation. So these are examples. So suppose you plan to go backpacking around Europe after you finish the university in 2 years. And if your saving account at the bank pays 6%, how much money do you need to set aside today to have 10,000 when you leave for Europe? So again, when I do any finance question, I will prepare a timeline. Right? On the timeline, I will address the amount of money and the timing of money. So you can see 2 years, I have a timeline, year 1, year 2. Right? $10,000 when you leave for Europe 2 years from now. So $10,000 2 years from now, right? Rate 6%, and we like to know present value. So you can do the calculation by the equation or by your hand. So PV is FV divided by 1 plus I with power of n. Then FV 10,000, I 6%, number of period 2 years. Finally, you have your present value. Okay. So this example should not be a problem. So let me use another example for you. And we use the Excel to do the calculation. Right? So you need 1,000 in 18 years for your daughter's education. You earn 6% per year. How much do you need to invest today? All right. Again, when I do any question, I prepare the timeline. All right. So you can see $150,000 in 18 years. So this is the future value, later money, $150,000, 18 years from now. Right. The rate is 6%. How much you need to invest today? This is our PV. Right? So again, I know we have 4 variables on the timeline, and they have a relation. By given any street of land, we may calculate the force. All right. So you can use the Excel to do the calculation. FV, number of period, the rate. So in Excel, you can either enter 6% or 0.06. It's fine. All right. Then you compute the PV. Please note, I add a negative sign to the PV, right, to make the result positive. So when I use Excel or financial calculator, I know PV and FV will have an opposite sign. That means one is positive, the other one is negative. Okay, that means one is inflow, the other one is outflow, right? You can also use a financial calculator, right? I know now we do all the assessment component online, so students will prefer using Excel. But if you want to have the finance certificate, you cannot use Excel, right? You can only use a financial calculator. So the idea is the same. You can see this variable on your financial calculator. You just enter the input variable or non-variable, then compute the output variable or the unknown variable. All right. So let me show you the process. Right. Just show you one time. So the idea is the same, but when you do the financial calculator, please clear your data you entered before. So you can see I clear the data I entered before. All right. Then we enter the input variable. I have 150,000 for the future value. Okay. Then number or period, 8 year, 6%. Please note, when you use financial calculator, you enter percent, not 0.06, 6 for interest rate. Then you want to compute PV, compute PV. So this is your result. Right? Negative means PV and the FV, they have an opposite sign. Right? So financial calculator, the idea is the same. All right? When you use the Excel, there's one reminder. When you use a PV formula, you have to follow the order. That means the first variable is red, the second variable is NPER, final variable is FV. 0 is PMT. We will discuss PMT in next chapter. Here, you just enter 0. But when you use a financial calculator, you don't need to follow the order. Right? You don't need to follow the order. So this, for me, is a difference between Excel and the financial calculator. All right. So because now we do the test online, so you can use Excel. It's fine. However, when you do any question, I will ask you to draw the timeline. So for me, that is important. Right? Calculation for me is minor. Right? We have Excel to do the calculation. However, the concept of the finance is important. Okay, so now we have next slide. You can see we address two important relations in present value. So relationship 1, for a given interest rate, the longer time period, the lower present value. Right? So we give you an example here. What is the present value of $500 to be received in 5 years or 10 years if the discount rate is 10%, right? So you can see when I see the discount, future money involve risk. So we have discount. So $500 in 5 years, future money. The future money in 5 years from now or 10 years. Right? So we can do the calculation. You can see the present value is here. And the result is clear. The longer the time period, the lower present value. So again, this is my handwritten note. We copy the PV equation here. N is our number of period. So the longer the time period, when N is going up, present value will go down. All right? So I give you an example. For example, like our government like to, delay our retirement age from 65 to 68. So when I see the news, I know this is not good news to us, right? Because the longer time period, right, the higher retirement age, the lower value of my super, right? One more example for you, my daughter ever talked to my wife, she say when she grow up, she will buy a house to us, right? So my wife is very happy. But for me, it's not a very good deal because, a house when she grow up could be 40 years later, 40 years from now. So the present value is very low because the longer the time period, the lower the present value, right? Okay. The next or next relationship, right? For a given time period, the higher the interest rate, the smaller the present value. So again, we give you the example: $500 in 5 years, interest rate 10% or, and you can higher interest rate, the smaller present value. So again, my handwritten note here. So again, I copy our PV equation. I is our discount rate. You can see higher discount rate, lower present value. And let's think about the concept behind the relation. I is a discount rate. Discount rate is the required return. When I see the required return, I am thinking about risk. Higher risk, higher required return, higher I variable, lower present value. All right. So higher risk, higher required return, higher discount rate, lower present value. Okay. All right. We finished the discussion on present value. For me, present value is an important issue in finance. When we talk about value, we focus on present value, right, rather than future value. Okay. So let me review some key concepts for you. FV and the PV, the equation, they are the same, right? So this is the FV equation. This is the PV equation. Right? So when I see the present value, I am thinking discounting. So discounting is a process to find the present value. So we move the money backward to today to have the present value. On the other hand, compounding. Compounding is to move the money forward on the timeline. Right? So I know the difference between compounding and discounting. Variation, chapter 8, we have bond variation. Chapter 9, share variation. Chapter 10, project variation. I know two important relationships in present value. The longer the time period, the lower present value. Second, the higher the interest rate, the smaller present value. Okay. In the calculation, I know how to use Excel to do the calculation. So present value formula, right? You have to follow the order of the input variable. The first variable is rate. Second variable, number of period. We will discuss PMT in next chapter. Final variable is FV, right? Okay, next topic, interest rate or our I variable. Right? So you can see before I show you the discussion, I know the 4 variables on our timeline. So 4 variables on our timeline: FV, PV, I, and the earn. Right? In our previous discussion, we have discussed PV and FV. Now we discuss the I variable. And you can see our final topic is the N variable. Right? So finding the interest rate. In finance, some situations require you to determine the interest rate or discount rate for a given future cash flow. This situation typically arises when you want to determine the return on an investment or cost of a loan. So here we give you a highlight a few keywords. Interest rate is a key variable in finance, and we have different definition of interest rate. So interest rate is also a discount rate, right? And it's a return to investor. It also a cost to the borrower. All right. So I hope student you know we have different definition of the interest rate, and the interest rate is an exchange rate between today's money and future money. All right. So now we like to find the interest rate. So we give you a few examples. So this is our example 1. So you buy the bond today for $90. And 20 years from now, the company will pay you $1,000, only a lump sum payment at maturity. What would be your return on the investment? All right. So again, when I do the calculation, I will prepare the timeline. So you can see this is our timeline. Right. So you buy the bond today, $90. I use negative, mean outflow, right? And the company will pay you $1,000 at maturity. Maturity 20 years from now. So 20 years from now, you receive $1,000. I use positive to present inflow, right? Then we like to know the I, your return on the investment, the I variable. So you can see this is our FV equation. So I enter the input variable, right, or non-variable, $1,000 FV, $90 for PV, right? Then number of period, 20, and we like to know the I variable. So you can do the calculation by your hand, right? Just move the I to left hand, all other number to the right hand of the equation. This is the detail. However, I will not show you the detail. Finance is about money. It's not about math, right? We don't need to do the math by our hand. It's not necessary, all right? So what I remember is the timeline, all right? And I know I can use the Excel or financial calculator to do the relation. The idea is simple. They have a relation, right? By given we have 4 variables in the relation. By given the 3 variables, I may know the false. This is what I remember, all right? So next slide, we give you the example for Excel, right? So this is our example. $30,000 to invest, and you need $45,000 for a down payment for your house, right? And you want to buy the house in 2 years. What rate of interest do you need to earn? All right. So we have the Excel here. However, before I use the Excel, I will draw the timeline. All right. This is my timeline. Right. So we need $45,000 to buy the house, the down payment for the house, 2 years from now, right? And today we have $30,000 to invest. So this is my timeline. And what the interest do you need to earn? So what we want to know is I variable. And you can see 1, 2, 3, 4. 4 variables. They have a relation between the 4 variables. All right. Then you can see I use the red formula in the Excel. So red formula is here. Given PV, FV, and the number of period, we have the red. But here I need to make a note, the sign, negative sign. So we add the negative sign for the FV. So you can see FV negative sign. The idea is here, PV and FV will have opposite sign, right? One is positive, the other one will be negative. It's a sign convention, right? If you don't do so, Excel will give you the wrong answer. I mean, the I, it will tell you this variable is unable to calculate the variable, right? So PV and FV, please remember, you have to add a negative sign to either one of them, either PV or FV. Okay. So again, in addition to Excel, you can also do the calculation by financial calculator. All right. So let me show you one more time. So it's not a problem. So before you do the financial calculator, clear the data. So I clear the data before I do any calculation, right? Then you can see 45,000. Sorry. This is our future value, all right? Then 30,000. This is our today's value, present value, but one of them should be negative. So our present value, I use negative, right? Then present value, okay? Number of period, 2 years. 2 is our number of period. Then we compute the I variable. This is the result. Please note, in our financial calculator, this is a percentage, around 22.47%. Okay? All right. We finished the discussion on the interest rate. Again, let me review the key concept for you. So for me, interest rate is a discount rate. Interest rate is a return to investor. It's also a cost to the company, right? So I can do the calculation for the rate formula in the Excel, right? So the rate is a function of number of period, PMT here 0, PV and FV. And when I use Excel, I remember the sign convention. So either PV or FV as a negative, right? So again, this is our original equation. So you can see, given FV, PV, and N, we can find the I variable. Okay, next slide. So now we are going to find the number of periods. So again, we give you an example. So suppose you would like to purchase a new bike. The dealer will finance a bike you want if you make a deposit of $1,175. Now you have only 1,000. If you can earn 5% by investing your money in a term deposit, how long will it take for your 1,000 to grow to $1,175? All right. So you can see I highlight the keyword, how long. So number of period is about the time. How long? How long will it take your money, $1,000 today, to grow to $1,175? So again, when I do the finance question, I prepare the timeline. So you can see this is the timeline I prepare, right? So today you have $1,000, right? And you hope your money can grow to $1,175, all right? Then interest rate is 5%. You want to know how long. That means your time or number of period. Right? So again, 4 variables, they have a relation. Right? By given 1, 2, 3 variables, we may know the force. All right. So after I have timeline, calculation for me is not a problem. So we use our original equation. FV, the money, the later money on the timeline. This is 1,000 $175. And the PV is a earlier money on our timeline, right? Earlier money here, $1,000. Our rate is 5%. Now we like to know the number of period, right? So again, you just move the n to the left hand of the equation, all other number to the right hand of the equation. This is our final number, right? Number of period, right? Ln is a natural log, but however, I don't want to spend time to discuss the natural log. It's not necessary, all right? I know I learned natural log when I was a high school student, but it's not necessary. What I remember is here, I have 4 variables for the relation. By given any 3 of them, I may know the force, all right? So this slide just for your reference. Our focus will be the NPER formula in the Excel, right? So this is our equation. So how long will it take for your 1,000 to grow to $1,175? So again, you have the timeline. Then you have the input variable, right? So you have present value 1,000, future value here, red 5%. Okay, sorry, this is a typo. Should be sent as 0.05. Okay, the 5%. Then we compute the number of period using the NPER formula in the Excel. Again, I like to highlight the sign convention. PV and FV, they have the opposite sign. So here I put the negative sign on the FV. Okay. Okay, so we finished the calculation, we finished the discussion. However, before we finish the chapter, I'd like to give you some tips for solving the time value problem. So this first tip is most important tip for me. Draw the timeline, right? You have to draw a timeline and insert the cash flow, both in and out. I mean, inflow, positive, out, cash outflow, negative, at appropriate prices. That means the timing, all right? So you enter the amount of cash flow and the timing of the cash flow on the timeline. Right? Next, identify which 3 variables are known and what are the missing false one. Right? Then we put the non-variable into the equation, either PV or FV equation, and solve for the unknown, as per example we showed you before. Right? So you can do the calculation by your hand, or you can use a financial calculator or Excel to solve the question. However, again, I like to tell you, you have to draw the timeline. Right? For me, that's the most important tip. Okay, we finished the chapter. You can see in this chapter, we show you how to compute future value, present value, return, and the number of periods, right? The idea will be the same. So let me review the final topic for you. So number of periods. So when I see a number of periods, the idea is how long will it take for PV to grow to FV, all right? So PV is the earlier money, FV is the later money. So number of period is about how long, right? I can use the NPER formula to do the calculation. Please note, when you use the Excel, remember the sign convention. So either PV or FV should be negative, right? One is negative, the other is positive. Yes. So you compute a negative N, that means you have forgotten the sign. All right, you can try yourself. All right, we have several examples for you, and you can do yourself. If you have the negative number of period, that means you have forgotten the sign. So again, this is our original equation. Given FV, PV, and I, we may calculate their number of period. Right? So I have a few questions for you. However, I encourage you to do the question yourself. All right, so we have the question for FV, question for PV, question for red, and question for number of period. And I have the answer here. All right, so when you do the question, draw the timeline and use the still. If you get the wrong answer, please double check the sign convention. So FV and the PV, one of them should be negative, the other is positive, right? Okay, we finished the discussion on this chapter. Before we go, let's recall our attendance. So give me a minute, we'll show you the QR code. Okay, student, the QR code is ready. Please use the code to record your attendance. Thank you for attending today's lecture. Have a nice weekend.